Welcome to another video on my series on not only building an Ironman, I don't want to call it suit because I'm not going to wear it, but an Ironman figure that will be controlled by ESP microprocessors. In the previous video we looked at activating the helmet, which was pretty simple actually, because there were only two servos that needed to be synchronized to open and close the face shield and then turn on the LEDs for his eyes. But now we're going on the little bit more complex part, being his upper body. And there we are actually going to work with multiple microprocessors being responsible for multiple activities. And in this case, we'll start with his shoulder. But what's so complex about that, might someone ask? Well, there are two flaps on each side of the shoulder, one for the right, one for the left. Underneath each flap is another mechanism to raise and lower his missile launchers. And what I want to do is be able to operate each servo action separately, but also create an animation where with one single command, both shoulders open, missile launchers raise, and then after a while lower again, and then shoulder claps should close. So a bit more action than just opening and closing the face shield. If you're totally new to this topic, I would highly recommend you watching my first videos where I really in detail explain how to install ESPHome on your local computer, how to flash your microcontroller, how to wire the servos to the microcontroller and so on. And I'm gonna skip this in this video because I assume that you either know what you're doing or that you stop here and jump to my previous videos and watch those. Before we jump into programming our ESPs, let's take a look at ESPHome and what we will end up having as a configuration and with our ESPs. You will probably remember the Ironman helmet ESP from the previous video. This video we're going to build the Ironman shoulders ESP. And for the moment, please ignore Jarvis. We will talk about him in one of the upcoming videos. So what's the big difference going to be? If we look at the Ironman helmet, it's a really simple and straightforward UI where we can trigger the buttons or the actions to close the helmet, open the helmet, and individually manipulate the LEDs for the lights. And on the right side, we have the log level output, and that's more or less all we can do on our helmet. That's all the helmet needs. If we now jump over to the shoulders, you will see that there's much more going on. First, that should catch your eyes is that the design, the layout is totally different to the one from the helmet. This is the web server version 3 that our ESPs provide, and in our helmet we just use version 2. Can be easily be changed, and you will see in the next video how. So what else is different? While in the Ironman helmet we just had the list of actions, in the shoulders website the ESP offers us a bit more flexibility. We have different groups addressing the actions that we can do for, in this case, the right missile, so right shoulder side, left missiles, and both sides. And within these groups, especially right and left, we have the different separate actions that I can initiate, so the buttons from our ESP code. And on the right side, we again have our log as expected. So this is the UI. Now let's jump into the source code and, as in the previous videos, look at the different elements of the source code for the Ironman shoulders. It all starts again with the base definition for ESPHome, where we define the name for the ESP and the friendly name for the ESP. This is again followed by the definition of what kind of microprocessor we have. In my case, it's again the ESP8266, and they're built on a Wemos D1 mini board. We can ignore the logging and the commented out Home Assistant integration. I do allow the system to get over-the-air upgrades. In the Wi-Fi section, again, there's the connection definition, how to connect to my local Wi-Fi, and if that doesn't work, the ESP will act as an access point by himself, and you will find it as a Wi-Fi network called Ironman Shoulders with the following password. Now, here in the section Web Server, we're going to see the first changes to what we've done in the previous videos. Our web server is now here calling for version 3. Version 3 offers the capability of sorting groups. Those were the sections that you saw on the web UI. And here is always the definition for such a sorting group. So each sorting group gets a unique ID, a friendly name, and a sorting weight. And the sorting weight then defines in which order this group is supposed to be shown on the website. Output is as we had in the previous video, where you have to add one section for each of the servos that you want to interact with and define on what pin that servo is connected to. Then we define our servos as in the previous videos. In my case, it's like the clavicle right, missile right, clavicle left, and missile left. And each servo having their own definition on how long they should be powered on, that's the auto detach time, and how fast they're supposed to do the action. Then we get into our scripts, and here it's getting a bit more fancy than in the previous videos. So we have one script that we call Open Right Clavicle script, and all it does is interacts with the servo called clavicle right and puts it into the position -100%. And again, this percentage is something you will have to find out by slowly starting with lower numbers, doing updates on your ESP and setup, and then finding the correct numbers. So as said, this is Open Right Clavicle. Then for Open Right Missile script, we're sending -60 to the servo called missile right, and the same goes on for the other side. Here you see how I concatenated the scripts that I built above into one script. So there's an open and close right missile script that first calls the script Open Right Clavicle, then waits for 2 seconds, then calls the Open Right Missile script, waits for 10 seconds, calls the Close Right Missile script, waits for 2 seconds, and then finally calls the Close Right Clavicle script. So this is the sequence where I don't have to press each and every action, but press or initiate one script and it does everything for me. And here's the same for the left side. The script to open the clavicle, open the missiles, close the clavicle, close the missiles, and the combined script in opening everything, closing everything. Here in the button sections, as we have many buttons, I will just start explaining the interesting ones. So we have a button here that's called Open Right Clavicle. On the web server, we give this button a sorting weight of 10. And again, the sorting weight will be the number that the web server uses to put the different buttons in a specific order on the website. The interesting thing here now is that we don't only have a sorting weight, but we also reference the sorting group that we created further up in the source code. So we'll add this button to the sorting group called sorting group right missile. And then we give this button a unique identifier, we select some icon, and if someone presses this button, we execute the script open right clavicle. So the same will happen for a button called activate right missile, which has the sorting weight 20, so it will be shown after open right clavicle, because that just makes sense to first open the flap, then activate or open the missiles. So here you have all the different buttons assigned to the different sides and the sorting groups. The only different button is down here, where we have the fire all missiles action, which is aligned to the sorting group both missiles, again that we created on top, and if the on press event happens, so someone presses the button, he will execute not one but two scripts, the one for the left side and the one for the right side. And that's actually all that needs to be done for the website and the action that you've seen before. So we can again save here, we can install it, we'll do a wireless install. So successfully uploaded program, we can close here, we can close this, we can go back to our shoulders, reload it just to make sure that the ESP is really still responding. And he was not yet ready, I was too quick, but here he is now. So this is all the code that needs to happen. I hope this was helpful and useful to you and you could learn something. If you did, leave a comment, leave a subscription. It'll help the algorithm. Thanks.